Hello students, welcome back to your channel Learning Point. Today we are going to understand parametric functions, the last type of your differentiation chapter, which is a part of your 12th Commerce new syllabus 2020. So guys, let us first see the definition and understand what is the meaning of parametric function. Then of course we will also see how to find out the derivatives of the parametric function. The basic videos or the basic types of functions I have already covered in my previous lecture. The link is provided in the description box. Please check out those videos so that you understand the entire chapter very nicely. Let's start. When two variables are expressed in terms of third variable, then we call it as a parametric functions. So students, let us understand this with the help of an example. Suppose if I have x which is equal to 2t plus 1 and y over there is equal to 3t square minus 2t plus 4. So I can see over here that the variable x is expressed in terms of t, variable y is also expressed in terms of t, and the question always remains the same in this chapter to find the value of dy by dx. Here x and y are expressed in terms of t. So in order to find the value of dy by dx, because the variable over here is t, I have to differentiate x with respect to t. For variable y also it is expressed in terms of t, so we have to differentiate y with respect to t, and then we will divide both the derivatives in order to get the value of dy by dx. Obviously I'll explain you how we do this step by step everything. So let us start. We have to say over here differentiate x with respect to t. So what is derivative of x with respect to t? Dx by dt. So it is 2 into derivative of t plus the derivative of 1. 2 is the coefficient, so we will leave it as it is. So you will get over here 2 into 1 plus 0 because 1 is a constant. So you get this value dx upon dt is equal to 2. Give it as equation number 1, and then we will repeat the same procedure for the variable y. We will say over here differentiate y with respect to t. So on the left hand side we will get dy by dt, and on the right hand side I have to take the derivative of each and every term over here. So it is 3 times derivative of t square minus 2 times derivative of t, that is 2 into d by dt of t, and plus the derivative of 4. So now guys, this 3 is the coefficient, so nothing can be done with that. T square, derivative of t square is 2t minus 2 into derivative of t, which is 1, plus 0. So what I can do over here is, guys, if you see carefully, 2 is common to both the terms. So if I take out that 2 common, I get in the bracket 3t minus 1. This is our equation number 2. Now what is the question? It is asking us to find the value of dy by dx. So in order to find the dy by dx, what we have to do over here is, we will say divide equation 2 by equation 1. So I get dy by dt in the numerator divided by dx by dt. So I get this is equal to 2 into 3t minus 1 divided by 2. So now guys, dt and dt will get cancelled off, as well as 2 and 2 will also get cancelled off. So we are left with, on the left hand side, as dy by dx, and on the right hand side it is just 3t minus 1. So students, that is the way we solve the questions which are based on parametric functions. I'll give you one more example, guys. It was example number 1. Now let us see example 2. If suppose you are given u is equal to log of 3x plus 1, and if I am having over here v is equal to 5 raised to power 3x plus 1. So if we come across this kind of a sum, our question over here is to find the value of du by dv. So when we want to find the value of du by dv, what we will do over here is, we will start with differentiating u with respect to x, because u is expressed in terms of x, as well as v over there is expressed in terms of x only. Therefore, when I want to simplify this, I will get du upon dx is equal to, now when I have log of 3x plus 1, it is in the form of log of fx. What is derivative of log fx? It is 1 upon fx multiplied by derivative of fx. So guys, I consider this 3x plus 1 as fx. So therefore, what I get over here is 1 upon 3x plus 1 multiplied by derivative of 3x plus 1. So this 1 upon 3x plus 1 is kept as it is, and derivative of 3x, so it is 3 into 1 because derivative of x is 1, plus derivative of 1 which is 0, so I get plus 0. So I get the answer over here as 3 upon 3x plus 1. This is our value of du by dx. We give it as equation 1. Then we go to v and we say over here differentiate v with respect to x. So now when we want to differentiate v, derivative of v will be dv by dx, that is equal to, this question is in the form of 5 raised to 3x plus 1, which is in the form of exponential function a to the power fx. So what is the answer for a raised to fx? It is a raised to fx multiplied by log of a multiplied by derivative of fx. So here value of a is 5, so the answer will be 5 to the power 3x plus 1 because fx is 3x plus 1 multiplied by log 5 and multiplied by derivative of fx, which is 3x plus 1. So what do you get? 5 raised to 3x plus 1 into log 5, these both terms are left as it is, and when I multiply with the derivative of 3x plus 1, I will get over here 3 into 1. So finally I write 3 into 5 to the power 3x plus 1 into log 5. This is my equation 2, which is the value of dv upon dx. Now students, as you can see, I have to find the value of du upon dv. What we will do is, I will divide equation 1 by equation 2. If you observe the previous sum, we had written d second term, the equation 2 divided by equation 1. The reason is that you have to observe what element is required in the numerator, and then depending on that you have to decide whether equation 2 will be divided by 1 or 1 will be divided by 2. Okay guys, so I will write over here equation 1 divided by equation 2. So what do we get first? Du upon dx divided by dv upon dx. And guys, what should be there on the right hand side? It is 3 upon 3x plus 1 divided by 3 into 5 to the power 3x plus 1 multiplied by log 5. Now over here dx and dx will get cancelled, as well as 3 and 3 will get cancelled. So what are we left with the elements on the left hand side over here? It is just du upon dv. On the right hand side it is 1 upon 3x plus 1. And guys, what about the next term? If suppose I consider this is entire term divided by 1, so it becomes a fraction upon the another fraction. So denominator, if I take in the numerator, it becomes reciprocal, and therefore what I will get over here is 1 upon 5 to the power 3x plus 1 multiplied by log 5, and hence my answer comes out to be du by dv is equal to 1 upon 3x plus 1 into 5 to the power 3x plus 1 multiplied by log 5. So this was the second type of question where we have to take equation 1 divided by equation 2. Let us see one more type of question in this parametric function, guys. I will take over here example 3. The question comes like this. Differentiate e to the power 5x square plus 2 with respect to 9x square minus 2x plus 1. So if suppose I am given this kind of a question what I have to do is I have to differentiate the first function with respect to the second function. So what I do is I assume the first function as u and the second function as v. So the question changes to differentiate u with respect to v, and we know that derivative of u with respect to v is just du by dv. So guys, you just have to find the value of du by dv, but he has given the question in a slightly different format just so that you guys should know how to apply the terminology of the differentiation. So I will now start with my answer. I will say over here, let u is equal to e to the power 5x square plus 2 and v is equal to 9x square minus 2x plus 1. So yes guys, I get over here, therefore differentiating u with respect to, not v, sorry, with respect to x. So derivative of u is going to be du by dx. Now the value or the variable e over here is actually in the form of e to the power fx, and e raised to fx is nothing but e raised to fx itself multiplied by derivative of fx. So when I take the derivative of this function, I get the answer as e raised to 5x square plus 2 multiplied by derivative of 5x square plus 2. So this e raised to 5x square plus 2 comes down as it is, and derivative of this term, 5 is the coefficient, derivative of x square is 2x, so you get this as 5 into 2x. Derivative of constant 2 is equal to 0, so we just leave that. Therefore I get du by dx is 10 into e to the power 5x square plus 2. We give it as equation 1. Then we will see how to find the derivative of v. Obviously that v is a very easy function over here guys. Differentiate v with respect to x. So you will get over here dv by dx is equal to 9 into derivative of x square, because 9 is the coefficient, 2 into derivative of x, and derivative of 1 is 0, so we can directly put that 0. So it is 9 multiplied by 2x minus 2 multiplied by 1 plus 0, whether you write or don't write, it is your choice. If you observe carefully, 2 is common element to both the terms over here. Therefore, I write over here 2 common and 9x minus 1. Equation 2. Now guys, when we want to find the value of du by dv, as I told you some time back, you have to observe which element is required in the numerator, and then depending on that we will decide. So because I want the numerator as du and the denominator as dv, therefore I will say over here divide equation 1 by equation 2. So I get this is du upon dx divided by dv upon dx. So guys, what do we get on the right hand side? Numerator is 10 into e raised to 5x square plus 2 divided by 2 into bracket 9x minus 1. Now let's cancel off whatever terms that gets cancelled. This becomes 5. So students, your final answer is du by dv is equal to 5 times e to the power 5x square plus 2, and that is divided by 9x minus 1. So guys, that is your answer for the value of du by dv. So I am sure you must have understood the parametric functions applications, how to solve the parametric functions. In the coming video, I will be putting all the sums of the exercise number 3.5 of your 12th standard new syllabus textbook. Thank you.